Good morning, everybody. Today we are going to talk about some general elements about heat pumps. The different types of heat pumps. There are three main types of heat pumps, depending on the source from which the thermal energy is taken. Aerothermal heat pumps are those where the thermal energy is captured from the ambient air. The second group, ground source heat pumps, are those systems where the thermal energy is captured from the ground. And finally, hydrothermal heat pumps, which use the heat from water, groundwater, lake, and the lake in the soil. General principles. Different types of heat pumps exist in the market, but they all work according to the same principle. The recovery and optimization of calories present in the external environment and/or of waste heat. Heat pumps recover the calories present in an external environment, air, water, soil, but also those from waste heat and redirect them to the heating network of a building. A heat pump consists of four main elements: a compressor, an exchanger to capture the energy from the outside, evaporator, a second exchanger to release it inside, condenser, an expansion valve. Heat pump general principle. Here we see a general summary diagram from AFPAC French Heat Pump Association. Definitions. Compressor is a machine used to compress a compressible fluid, for example air, to a desired pressure. A condenser is a device whose main function is to liquefy, condense steam. It is to say to change it from a gas to a liquid by means of a cold surface or heat exchanger kept cold by the circulation of a refrigerant. Heat exchanger. A heat exchanger is an element that allows the transfer of heat between two fluids through a wall, thus without mixing them. The material used in the heat exchanger must be as conductive as possible in order to limit heat loss and promote heat exchange. For the exchange to be possible, the two fluids must have a different temperature. Pressure regulators. Pressure regulators, more commonly known as pressure-reducing valves, are devices designed to regulate the pressure of a gas to a stabilized value. This expansion pressure is kept constant for a given range of flow rates, even if the upstream pressure is variable. Evaporator. The evaporator captures energy from the cold source by converting a fluid called refrigerant from a liquid to a gas state. Refrigerant or coolant. A refrigerant is a pure fluid or a mixture of pure fluids present in the liquid or gaseous phase, or both, depending on its temperature and pressure. The main property of the refrigerant is that they evaporate at a low temperature under atmospheric pressure. Refrigerants are used in cold production systems, air conditioning, freezers, refrigerators, and solid servers. Hydrothermal heat pumps. Hydrothermal heat pumps are, for example, air-to-water heat pumps and air-to-air heat pumps. For air source heat pumps, heat is taken from the outside air and transferred into the inside of the building. This transfer takes place either in the ambient air or in the hot water circuit of the heating system. Air-water heat pumps. The air-water heat pump takes the heat from the air and converts it into heat. This heat is then transferred to water, which is fed into a heating network. Some air-to-water heat pumps can also provide domestic hot water. The air-air heat pump captures heat from the outside or inside air, depending on requirements. This is known as a reversible air-to-air heat pump which provides both heating and cooling for the home. To operate, the heat pump needs at least 2 units. One, located outside, recovers or evacuates in cooling mode the calories from the air, and the other inside diffuse or captures in the cooling mode the air within the home. Geothermal heat pumps. Geothermal heat pump uses the energy of the ground to heat the room by horizontal collection, by vertical collection, or groundwater collection. Geothermal heat pumps, water-to-water and ground-to-water heat pumps operate in different ways. The heat is taken directly from the ground from groundwater heat pumps and from a water table, lake, or river for other ways water-to-water heat pumps. Hydrothermal heat pumps. The hydrothermal heat pump can be used when the house is located next to a water source. The system draws heat from the water and uses it as a source of heat for the house and for the domestic water. For cooling, it can be used in rivers in summer. Administrative procedures must be carried out for the installation of a hydrothermal heat pump generally. The water-to-water heat pump is very simple to operate. It draws on the calories present underground in the water of the water table, lakes, or rivers. These calories are then transferred to the hot water circuit of your heating system to heat the house or domestic hot water, but also to cool your home. Whatever the outside temperatures, the efficiency remains high. Indeed, composed of a hydraulic module located inside the house and an outdoor unit located outside, the heat pump can combine up to 3 functions: heating the house, cooling the house, produce domestic hot water. I hope you found this presentation interesting. Here are some sources if you want to learn more. Feel free to ask questions or make comments in the comment section. Thank you and see you soon.